Hi, everyone. First of all, thank you so much for your support yesterday. I got a lot of compliments after the Ignite, and I really appreciated it. So this morning I want to talk about scaling CI/CD, and my name is Christine, like Josh said, and I'm from ThoughtWorks. I do not have a Twitter handle, sorry. I got a couple of questions about that too, so you won't see that on any of these slides, but also thanks for the retweets yesterday, so I got to see some of those. So I'm from ThoughtWorks. So I'm out of San Francisco, and what we do at ThoughtWorks is we're software consultants. So we travel around the country, we consult with clients, we build different technologies for them. We kind of help revamp their software delivery practices. We introduce Agile, we do a lot of different things. It's a really great company. You can check it out or come talk to me after about it. But other than that, if you want to know more about me, you're welcome to talk to me after this presentation. So what I'm not talking about today, and I wanted to just talk about this to kind of like set the boundaries. So I'm not going to talk about the benefits of CI/CD. I'm pretty sure you're well aware of those. I'm not going to talk about whether or not you're doing CI/CD correctly. I'm not concerned with that. And I'm not going to tell you how to do CI/CD correctly. That's my job on a day-to-day basis, and I don't need to be doing that here also. But before we start, I wanted to go over some definitions, some working definitions of what I believe continuous integration and continuous delivery are and what they mean to me. And I hope that'll prevent some clarity throughout this presentation of what I'm talking about. So this might be repetitive for a lot of you, and I'm sorry about that, but I think it's important to set some context for this presentation. So I think continuous integration starts with a single source repository. And the single source repository is where developers keep their shared source of code, right? So you might have developer X who's pushing and pulling code from this repository, and they introduce it to their workstation, they're building out some feature, they run their automated tests, and then they push it back to that repository. You might have developer Y who also comes along and does something similar. Now developer Y might be working on a similar feature, they might be touching similar parts of the code base, but they don't have to worry about clashing with one another. And that's what continuous integration gives you. Because as they push and pull their code to the single source repository and to a main branch, not a feature branch, they're continuously integrating their code multiple times throughout the day. And the CI server is what helps ensures that that integration works smoothly and doesn't clash with one another. And the CI server is really just a tool for monitoring this repository, because every time it detects a change in that repository, it's going to check out the code, run some builds, run some tests, and ensure that that integration went smoothly. So what hardware is involved? Well, there's usually a CI server. You might be familiar with some of these tools like Jenkins, TeamCity, GitLab, CI, whatever. And then usually there's some build agents. And these build agents are sub-environments. So when the CI server checks out code, they introduce it to the build agents. The build agents have whatever environments needed to build and test the code. It's a sub-environment that's isolated from a developer's environment. So it ensures you don't run into the problem of, oh, this works on my machine, but not yours. So that's really what it's doing. So the CI server is running this automated tooling throughout the day to make sure the integration's happening smoothly. So what is continuous delivery now? Well, continuous delivery is the process of making sure that your code is always in a state that's shippable and deployable. And so this is an example of what a deployment pipeline looks like on a CI server. This is GoCD, for example. It's an open source solution. And the first stage of the pipeline might be build. And then the next stage of the pipeline might get kicked off, and that might be test. So as long as these two stages run successfully, you can ensure that your integration was successful with whatever developers are making throughout your team. And then what continuous delivery really means is making sure your code is always in a deployable state. And so CI servers often give you that ability to do one-click deploys. Sometimes that's manual, but sometimes it's automated, whatever you want to do. You can just click that button, go to deploy, and then your code's in production. And that's what continuous delivery is, in my definition. So with that, how many of you have a continuous integration practice or a continuous delivery practice? Great. Decent number of hands. So how many of you would say maybe you have just one CI server? All right, how many of you have more than 5 CI servers? Just to get a raise of hands. And I'm guessing everyone else falls somewhere in between. So we're operating on different scales here. And so that's why I'm going to talk about this, because sometimes when you're scaling CI/CD, it's hard to go from one CI server scaling up, and it's hard to start with 10 developers and go to up to 100 or maybe 300 developers, and working and supporting them throughout the way and making sure that the CI experience for them is something they enjoy doing, because it's something you want to promote. So as a lot of you know, there's a lot of benefits to CI/CD. You can detect bugs early and often, frequent deployments, collaborative develop environment, and rapid feedback. These are just like some of them that they give you. And most of you who have a CI service have chosen either self-hosted CI or CI as a service. So self-hosted CI means you manage this infrastructure yourself, or somebody in your team or organization does. And CI as a service means you've bought that solution. So you don't have to manage the infrastructure, somebody else manages it for you, and all you do is you write the deployment pipelines and you push your code and watch it go. So this talk is mostly going to be focused on the self-hosted CI portion. So I'm sorry if I'm eliminating anybody from the pool of who it's relevant to. But I hope that it's going to be relevant to scaling any service overall, and also I hope it's going to reinforce whether you made the right decision when you chose CI as a service or whether you chose self-hosted CI, and how you can better make that informed decision if you haven't made that decision yet. So scaling CI/CD is an unexpected journey, much like scaling any service. You're going to run into a lot of roadblocks on the way. You're going to run into a lot of things you didn't expect and plan. You're going to get stalled for a few days. And I think it's really helpful to kind of have a map of where people might be able to warn you about where those blocks are. So you know when you might encounter them. You can maybe avoid some of them. And that's kind of what I'm going to try and give you today, is those blocks that my team recently ran into and how we overcame them, so that maybe when you go on this journey of scaling CI/CD, you won't have to deal with the same ones, hopefully. So the background of where this story came from, I work at ThoughtWorks, like I said, and we have a client. And usually at our clients, we try to institute some organizational change, encourage better software delivery practices, whatever, some overall transformation of how they do software and technology. At my most recent client, we were doing a lot of interesting things. We were building a microservices architecture and platform. And to enable that, we had to build a lot of things along with it. We were building blue-green deployments, which they didn't have before. We were building automation for everything. So even automation for code deployments, automation for infrastructure. It was a big change away from doing manual deployments. We were moving to AWS off of on-prem infrastructure and data centers, which was a big move for them. And all of this kind of took the adoption of CI/CD to be possible. Really, none of it would have been done as easily or as fast without CI/CD. So what did our initial state look like? Well, I was on a product team or an ops team, whatever you want to call it. We were managing the CI server and the build agents. We were using GoCD, and this is kind of what it looked like. So maybe we have 3. We actually started with a few more agents, but we had a CI server and some agents. The agents would build, test, and deploy, like I talked about before. And maybe we had 2 teams. We had 2 teams pushing to their source code repositories, and then the server would pull for those changes. And so it was on a pretty small scale, and we didn't really deal with any problems here. Everything was great. We had automation for our infrastructure, like I had said. So things were going pretty well. It was a pretty small scale, which I'm sure looks familiar to some of you when you start out with CI/CD. But a few months later, we had doubled in scale, and we continued to double effectively after that. And so that's when things started to get painful for us, and we started to notice some challenges that we encountered. So the first challenge was the Ci monolith. And so a lot of you know what a monolithic structure looks like, or a monolithic application. Usually it's a giant thing that's bloated. It has way too many responsibilities. It's doing too many things at once. It's hard to make changes. It's painful to work with. And that's what our CI server began. So as we doubled in capacity and we had more developers using it, it became difficult to make changes to the CI server. So how do you know if you have a CI monolith? Well, you can ask yourself some questions. The first is, do you have a single CI server catering to a variety of teams? So do you maybe have like 5+ teams all using the same CI server? Do you experience an increasing demand for build agents? So when people run their deploy pipelines, do you have people waiting for an extended period of time because there's no build agents available for them? Do you have a CI server that is under an increased load at peak hours? This might be CPU utilization or memory utilization. And then in addition to that, do you see visible performance degradation on your CI server? So visible performance degradation would look like the CI server slowing down and pretty much a loading icon most of the time. And that's what makes CI a really painful experience for developers, which is exactly the opposite of what we want. We want to encourage CI/CD. We don't want to make it painful to use the UI, in which case no one's going to want to do it. So how do you go about breaking down the monolith? Well, first of all, do you plan to scale for much more capacity? Some of you might be working in small startup teams. You might not have a lot of developers to work with, in which case a small CI/CD setup would work for you. So if you're experiencing some of these problems, increasing the CI server might just be enough, just increasing the memory that it has and whatnot. And that might last you for a little while, at least until you plan to scale. But if you do plan to scale, I would recommend breaking down your CI servers into separate responsibilities. So for each team that we had, we broke down a CI server for each one of them. So if we had a big data team, they had their own CI server. Infrastructure team, they had their own CI server. API development team, own CI server. Mobile, etc. They each had their own CI server with separate responsibilities. Yes, this introduced complexity in terms of the number of CI servers we had, but they were all essentially the same. And it was easy to make changes to them because we had standardized tools for them, but in the end, it made developers happy because they didn't really care about seeing each other's other pipelines anyway. But this introduces the question of how are you gonna manage those multiple CI servers? And so I've seen companies usually take two approaches. They do a self-service approach where the teams will manage them themselves, which introduces some complexity, or they do a centralized approach where they have an ops team like mine was managing the CI. And so this introduces a few challenges, and I'm not gonna tell you which one's right or wrong because that's gonna honestly be up to your organization and how it's structured. But most importantly, have a clearly defined strategy for how to create a CI server. And that's gonna be important because, and an equal sign is a bad representation for this, but I think what it really encourages is the ease of creation. If you have a standardized process, you can do it again quickly when you need to. You can also have rollback strategies because more often than not, you're gonna run into problems with one of them and need to roll back. You're gonna have a minor learning curve. So onboarding new people onto the team, whether you have a self-service team and they need to learn how to create a CI server, many people have done it before in the same manner, so they're gonna understand how to do it. You're gonna have a reduction in Snowflake servers. And with that, you're gonna have automated changes. So you're not gonna be making manual changes anymore. When you're managing 5 or 6 of them, why would you make manual changes to them? That's just too much complexity. So post Monolith, we broke it down. We had more teams than this, but they each had their own CI server. They're all happy. They're pushing to their code repositories. Everything's building smoothly. It's going pretty well until our next challenge. And that was managing pipeline duplication. So this is what pipelines look like in GoCD. We started to have a lot of them, and a lot of them started to look the same. How you typically would manage pipelines in a CI server, in case some of you are familiar with, you can manage them manually. So this is one way of doing them, entering them through the UI. That's just painful. Nobody would do that. So they also promote pipelines as code. And pipelines as code is a typical abstraction you see for almost all CI servers nowadays, and they usually describe the pipeline in terms of stages, build, jobs, tasks. These files can get pretty long, up to 60 lines long. So when we had a lot of pipelines that started to look the same, when you have 20 microservices and they each have the same build, deploy, test pipeline, just with different parameters abstracted from them, having a 100-line file for each of those is pretty unsustainable for growth and scaling. So like I said, we have all these pipelines popping up all over the place. They all look the same, and we needed to do something about it. So we kind of did a level up of abstraction. We pulled a level of abstraction up from the pipelines as code, and we made what we called pipeline plans. So it's gonna be a little hard to explain, but in pipeline plans, we abstracted the parameters that were most important to the pipeline as code. So for example, this is a Java app. And in a Java app, all that was really important about it was what Git URL is it pulling from? Is it gonna run certain tests, like semantic tests or integration tests? Is it gonna be a public API, or is it gonna be a private API? And this would get kicked off by a pipeline tool, Python, and then Python would create the pipeline as code that was necessary for it. But essentially, we didn't have to write that pipeline as code anymore because it was too many manual steps to write a 100-line file. So some examples of pipeline plans we had were maybe Java apps, Java libraries, mobile ones, Terraform, Ansible, you name it. Anything we saw duplication for, we wrote a plan. And this also encouraged developers to write their own plans because developers are the ones writing the pipeline. So an ops team, we don't really know exactly what pipelines developers needed, but now that they saw examples of what a plan looked like, they were encouraged to write their own. So as duplication was introduced, it created easier time for them and their teams to onboard and to create pipelines because all they had to do was write a file that was 9 lines long at this point. So we have a lot of pipelines now, and we have a CI server for each of them, and our third challenge was making our build agents effective. And so this was really a pain that I think the ops team felt and that the developers don't see. But why it's important is because your build agents are doing a lot of the heavy lifting. So your build agents might be communicating with Git, they might be pushing data to Splunk, they might be pulling from Artifactory and deploying to AWS and doing all this stuff. So they're doing a lot of work. And the change process for them is we would get a request, and we would accept that request. So maybe that request is install Golang on one of them. We need to build this app. And then we'd have a 15-minute delay. This is how long it took to install one more tool on our build agents because they had become so big and bloated with all the tools they had installed on them. And just installing one tool took 15 minutes, and then we were done with that. That doesn't include testing, figuring out whether the build agent works or whether it can deploy your application. And why this took so long is because we had, sorry, that's the bottleneck. That's that 15-minute delay we were trying to solve. But why this took so long is because we had 30 homogeneous build agents. Each of them looked the same. They each did the same thing. They were each equipped to pick up any build pipeline that came along and build it. And that doesn't scale easily. So these 30 build agents may have had a JVM, Python, Docker, Android tools, Terraform, Packer. This is a real case scenario, by the way. Ansible, and then GoCD native tools that were installed on the build agents. And this is just like a short list of them. They also had more specific tools, configuration, environment variables. It was managing a lot of complexity. And so it started to not be able to scale in order to build new complex pipelines that developers were introducing into our platform. So we introduced the idea of heterogeneous build agents. Build a build agent that has a specific job and responsibility. So build a Java build agent that's designated to deploy Java applications. Build a Terraform agent that's just like, its purpose is to build Terraform and apply it. And then build a Golang one, like we got the request for, that can deploy Golang applications. All right, and on to the last challenge. So our last challenge was managing the importance of high availability. And this is where we really messed up. We didn't do this right, and it's kind of a shame. But at this point in our story, we had 200 plus users using this. This has included business stakeholders, developers. We probably actually had more than that in terms of how many people were looking at it every day. We had 6 CI servers, we had 30 plus build agents, and 400 plus pipelines. These aren't big numbers, and they're not meant to be. When you're managing this on an even bigger scale, there's other challenges you're gonna face. But to get from 0 to here, high availability is definitely something you want to consider. So your CI server has become a lifeline for developers. It's exactly what they need to integrate their code effectively every day, and when they can't do that, bad things happen. So when the CI server catches on fire, the developers can't integrate their code effectively, and they're effectively stalled. They can push to their repo, but they don't know whether it's clashing with another person's changes, and most likely when that CI server comes up, all their builds are going to be red, which is exactly what happened. So our CI server was down for 8 hours. That's a whole day of work for developers. We had 15 failed production deployments. We took away their ability to do one-click production deploys. And we had 100 developers affected by the outage because we just took down one CI server. We didn't take down all of them, which is another benefit of splitting up your CI servers, by the way. But that's 800 developer hours. And this isn't the end of the world. You're not taking down everything that's customer-facing. But 800 developer hours, that's pretty darn expensive. You don't really want to mess with that and make that less effective than it already is. And the worst part about this is a pretty easy problem to fix. You can fix this by increasing load balancing. So you can have 3, which increases some complexity, but you can load balance across the clusters, so you have duplication. In case one server goes down, you have 2 more standing. You can increase it by having a backup server, so another server you're making the same changes to all the time that's ready to come into service as soon as you want. And at the very least, you can have a detailed disaster recovery plan well documented to know exactly what went wrong and how to recover from it. This took us about 4 hours of our day because we didn't have a disaster recovery plan in place. We had to figure out how to get our artifacts back, figure out what versions are in production. Everything that CI server gave us by automation, we didn't have anymore. And that was losing a lot for us. So in summary, there was breaking down the Ci monolith, where I talked about splitting up CI servers with separate responsibilities. There's managing pipeline duplication, so looking at pipeline as code if you're not already doing it, which you should be, and then maybe think about abstracting it a level further. Managing effective build agents, making sure they're working as efficiently as possible. It's easy to introduce changes, and they're doing their job. And then the importance of high availability. So making sure that your developers are getting all the benefits of CI all the time. So there's a difference between learning versus implementing. And I can stand up here and tell you all the things we did wrong and what we did right. And a lot of you can probably go back to your organizations and probably don't even have the control over what CI service you're using or what you're building. And I know that and I understand that. And that's a lot harder to do, is to implement change than to actually just sit here and learn it. But what I do as a consultant is I bring my experience to the table, right? I walk into organizations and I say, this is what I've done in the past. I've introduced some options for you. You can take what you want or you can refuse it. So I guess my ask to some of you from this presentation is, what can you bring to the table? So what can you bring back to your organizations, if any one of these, whether it's scaling CI/CD or scaling another service, and how can you introduce it to your organization to make your CI systems more effective and more secure? Thanks.
So you mentioned the heterogeneous CI agents. Do you recommend having them be like independent servers that are heterogeneous, or maybe just have like different Docker containers that you could use as build agents that are various suited for whatever language or framework you're using at the time?
Yeah, no, that's great. So that's some point I kind of grazed over that I meant to talk about. We actually did containerize our agents. That's exactly what we did. We wrote a Docker file to make specific build agents for each service we had. So I think that containerization is a perfect tool for that. Yeah.
So the question I have was, you said you have different CI servers for different departments in the same company?
Yes, CI servers for different departments in the same company.
Why would that be? I mean, why can't we use the same thing that you said, load balancing multiple CI servers, and the same thing is available for all the departments? Is that easier or is it difficult?
Is it easier to have?
Just have a set of CI servers, and then you have load balancer and all those things, but the same thing is used by all the departments.
Sorry, I can't hear.
Sorry.
Step 1 and step 4, yeah?
Yeah, that's what he's saying.
What about?
All your CI servers would be clustered.
Yes.
Why separate the CI servers
Yeah.
for each department instead of having a cluster of CI servers? Then anybody can use any CI server in the
Yeah,
company.
that's another way of scaling things.
Okay.
Yeah,
Okay.
you can
There's
do
no.
that.
Okay.
Yeah.
More questions?
I think I have the same question. I'm just going to try and ask it a little differently. But if your CI/CD platform supports horizontal scaling and load balancing, high availability, then is there still a benefit to having multiple separate CI/CD servers by department?
If it already supports all of that out of the box, then yeah, I'd probably say reevaluate having separate CI servers for each team. Because I think one of the benefits you get from it is, like, we didn't want developers stepping on each other's toes. So why would they be in the same CI server? There's other ways of avoiding that. But they didn't really care about other stuff anyway. So we didn't want them to see it. We didn't want them pressing the wrong buttons. And you can do that with access permissions in a lot of different ways. So,
Okay.
yeah.
Thanks.
Any other questions? Back here. All right. Let me get these guys real quick. All right. Who was it over here?
So to give you a background, I have been using GoCD for deployment and build purpose for like 2 years, last 2 years. I was curious about if there is any feature available to revert or roll back the pipeline just did. Is there any functionality available?
To roll back pipelines?
Yeah, so say suppose if I just build and deploy, I
Yeah.
simply want to roll it back from pipeline.
Yeah. Yeah, so GoCD has a specific feature. It's like, this is going to be very specific. It's a play with a plus button, and you can select it, and you can select the specific feature, like, or the specific version that you want to roll out. So whether that's, you can base that on a label in GoCD, or you can base that on a Git hash, whatever you want, and you can select a very specific commit that you want to roll out to production.
No. It's like I'm looking for the pipeline, whatever pipeline has just done, to revert it, from like it's not about the reverting the deployed thing. It's about yes, anything what pipeline just did, to revert it from there or to roll it back from
To
everything
revert-
from pipeline. You're talking about the to selecting the previous version and then roll it back. I was actually looking for any option which, like, going back to the pipeline, to reverting the pipeline.
Maybe we can talk about it after, if that's okay.
Okay.
And then I can
Okay.
get more details on it.